So in this example, it states the average credit card debt for a recent year was $9,200. 5 years earlier, the average was $7,300. A sample size of 35 was used for both figures, and the standard deviation was 1,920 and 1,870, respectively. Is there enough evidence to believe that the average credit card debt has increased? So let's just make sure that we understand, respectively. That means that the order is maintained. So the 19,200 is associated with the first, and the second is the 1,870 for the 5 years earlier. Now, with that said, first we're going to state the hypotheses. And according to our statement here, is there enough evidence to believe that the average credit card debt has increased? In other words, in terms of direction, it's getting larger. So the mean of today is greater than the mean of the past, we'll say 5 years. I'll just put the past 5 years. And that would mean that our null hypothesis is less than or equal to, and I'm just going to put today, and we'll say the past for the subscript for this mean up here. Second, so that's our first step. Second is to determine the critical values, and once again, you see this is pointing to the right. So this is a right tail. So we're going to draw our normal curve, the tail on the right-hand side. And according to our question, the alpha is 0.025, making the area from the center to there 0.475. And as before, when you go to the Z table, we should expect this value to be 1.96, but let's just double check that. So 0.475 is down below here. Okay, and that would make the value 1.96 as stated. So in this case, that's 1.96. Next, we're going to put together our Z-score. And so the Z-score in this case is equal to the difference between two means, the mean of today, sample mean, the sample mean of today minus sample mean of the past, and keeping the order straight down here. Actually, it doesn't really matter if you add them in different orders. What's important, though, is that the standard deviation and the sample size correspond correctly. Now, based on this information, I have the following: 9,200 minus 7,300 all over the square root of 1920 squared. And the sample size used there was 35. 1870 squared. And the sample size used here was 35 as well. This then gave me a value of 1900 on top, divided by all under the square root sign, getting us 1900 divided by 453.03106 4.17. And then that gives us a value of 4.19, 397,291, and then finally, rounded to 2 decimal places, 4.19. So let's go plot that, 4.19. So once again, 4.19 is in our rejection region. Okay. So you can see then our decision, I'm just going to put that up here, our decision then would be to reject H0 because it's in the rejection region. And once again, let's go see what that really means. So we're rejecting this statement, and we're going to not reject this. In other words, we're going to accept it to be true based on our sample data. Well, and that's a fine point. We're going to speculate that it's true. We can't say with 100% certainty because there's always that chance of error, right? So in this case, the mean of today is actually significantly greater than the mean debt of the past. So let's state that conclusion. So as stated, our sample data indicates that the population mean debt of today is significantly greater than the mean debt from 5 years past. And there we go. With that said, let's try one more example. I'll leave that up to you if you want to watch it, but once again, it's pretty straightforward. The 5 steps are there. And yeah, if you feel confident, you can move on to the homework. Otherwise, you can watch one more example.